Hi and welcome to video 6 on the annuities topic, and this is from Unit 4 Topic 1 of the General Maths curriculum. So we've just talked about formulas in the previous video, and there's a few of them, but there are 5 main variables in this case. So we have A, which is the amount, the future value, the amount at the end, and that's probably the easiest one to find. That's the one you want. That'll be the yay one. And we also have P, M, N, and I. Now, for P, M, and I, we just rearrange. There are some formulas where rearranging for I is going to be quite tricky. If I go back up to our formula list here, you'll notice that in these initial formulas, we have I appearing twice or 3 times. That's going to be quite tricky to rearrange for I. But if we're dealing with this formula here or this formula here, it might be doable because I only appears twice, but it's still going to be quite hard. So I don't expect you to be asked about I. P and M, no, are pretty easy, and we'll do some examples of those. N's also a bit of a problem. To rearrange for M, and this is only if it occurs once, we require logarithms, which you don't need to know, and you shouldn't know. And if you do, well, good for you. We could use trial and error. That's probably your best bet. And we could play around with recursion as well, depending on the situation, or maybe use a table. So maybe play around with some questions like that, but I anticipate most questions in the simple familiar, complex familiar realm will be A, P, or M. Don't forget the time periods as well. So if we're talking monthly, then you have to find and use I and N as a monthly rate and time period. But then if you find I or you find N, they will come out as months, and we might have to convert back to a yearly rate or to number of years. So let's have a look at some questions. Example 1 for today, for this video. Anand is saving for a new car. He needs $45,000 and already has $23,620. If he'd like to buy the car in 2 years and can earn a rate of 3.8% per annum, compounded fortnightly, how much must he save per fortnight in order to purchase the car? So we're dealing with A, P, M, I, and N, and we're going to write down the things we know and the things we need to know. In this case, A is 45,000. We need to save 45,000. His present value, P, is 23,620. That's what he has now. N is 2 years, but it's fortnightly, so times 26, and that's equal to 52. And I is 3.8%, but fortnightly, so divided by 2,600 to turn it into a decimal. M is what we're trying to find. We want to know how much must he save per fortnight now. That's our regular payments. So we're going to be dealing with the old formula, the big one, which is A equals P, 1 plus I to the power of N minus M, although we're depositing, so plus M, 1 plus I to the power of N minus 1 over I. And we're going to substitute into this formula, which is 45,000 equals 23,620, 1 plus I, which is 3.8 over 2,600 to the power of 52, plus M times 1 plus 3.8 over, it's a bit tiresome really, isn't it, to the power of 52 minus 1 over our I value again, which is 3.8 over 2,600. And there's our substituted values in. You should do all of these values as we go. But if I evaluate this, which means doing that, subtracting this, and then dividing through by that to get M by itself. So M will be equal to 45,000 minus 23,620 times 1 plus 3.8 over 2,600 to the power of 52. All divided by this bit, 1 plus 3.8 over 2600 minus 1 over I, which is 3.82600. Well, it comes out as 361.5065855 ... And I need to round this now to the nearest cent, but to actually save up the right amount, I need to make sure I round up. So that means that I get 51. I must round out. If I round down, even if it's natural to do so, I will not get to the right amount. I'll fall short, maybe by only a handful of cents, but it's still falling short. So mathematically, it's the incorrect answer. So there we have it. Our formula is written down, our substitution is written down, and then our calculations are done. Be really careful. Try and maintain your answer, or use a lot of decimal places, all of them that are available, or use the exact values, but it's best to maintain your answer if you can. Okay, we'll just go through one more example in this video, and that is a complex unfamiliar example with barely any space to do it. So let's make some space. Now you'll find that these kind of complex unfamiliar examples still don't necessarily tend to take that long. You'll see here that one component is a few lines. I showed multiple steps of working. When you get to the complex unfamiliar, you're probably doing 2 or 3 components. So yeah, it may take you a page if you work it well, but it may take you less than a page as well. So let's see how we go. Antonio is paying off a $20,000 loan. The charges include 1.2%, which, by the way, is amazing. So let's just keep that in mind. That's not going to happen really that often. 1.2% per month interest rate and $20 monthly service fee. So I need to pay $20 as well. Initially, he's paying off enough per month in order to finalise the loan exactly in 5 years. Unfortunately, the rate increases to 1.5% per month after 3 years. How much must he pay per month in the final 2 years in order to finalise the repayments on time? So, the $20 service fee is a bit of a problem we haven't dealt with, but we're actually calculating M. And there's a few things going on here. So in the first instance, step 1, we know that he's paying off a $20,000 loan. And we really want A, the final value, A, to go to 0, which means that we want the present value to be $20,000. But we're going to go back to that formula, which is the A or P, whichever one you call it, is M 1 minus 1 plus I to the power of negative N over I. It's our reducing balance loan formula, which is also that withdrawal loan formula. So where interest is accruing, but we're withdrawing money from it. And in this case, interest is accruing on the loan and we're paying off, which is kind of like a withdrawal. Now we just need to note that A and P are the same in this case. So I'm calling A 20,000. M we're trying to find. I is equal to that amazing 1.2%, but it's monthly, so over 1,200, which actually equals 0.001, so that's nice, and that's exact. And N is equal to 5 years, 5 times 12, which equals 60. And so what I'm going to get is I'm going to get $20,000 is equal to M times all this stuff. And if I put all this stuff in, 1 to the power of negative 60 over 0.001. My approach to this is to calculate all this stuff. So that's equal to M times 58.2072 some extra decimal points there. And then I can calculate M by dividing 20,000 by that. M is equal to 343 and this is amazing, 5999163. Now, I am feeling pretty comfortable about rounding this because that 5999, but again, we have to be really careful. So we'll say that goes on forever. That's the dollar amount and 343.60. But of course, we have to take into account there's a $20 monthly service fee. So the repayments are going to have to be $363.60. I've just added that $20 service fee. And the service fee is that simple. It's just we put the repayment in and the $20 is taken off. It has no effect otherwise. So that's a pretty easy bit to deal with. But that's how much he has to pay to complete the loan in exactly 5 years. And you'll note here that I have rounded up, so it will be completed, maybe to be completed by a cent early, I don't know. But unfortunately, the rate increases to 1.5% per month after 3 years. How much must he pay per month? So diagrammatically, he's taken this loan and he's repaying it down to $0. and we've got these repayments. But something changes here at the 3-year mark. And this is obviously finishes at the 5-year mark. So what really happens is we're repaying to there with the same M, but then we get the change and the interest rate changes, and now we have a new system we have to calculate. Now what we need first in this question is we need to know what he owes there. And then we can treat this as a whole new loan with whatever's left. So we've now got our part 2. Part 2 is to determine what he owes. So in this case, A is what we're trying to find, the future value. P is $20,000, that's what he owed at the start. M is what we just calculated, but I've saved M on my calculator. So $343 is effectively what is coming out of the loan, even though we're actually paying $363, and that value is saved on my calculator. I remains the same at the moment, I equals 0.001, and N is now 3 years, which is 36 months. I should say 60 up here. Okay, now we're back at this formula here because we want to know A and where we're paying. So if I shoot back up, we've got this withdrawal formula. That withdrawal phase there, we've got a minus in there. So let's throw this all together. A is equal to P, 1 plus I. In fact, let's just throw numbers in straight in here. $20,000, 1 plus 0.001 to the power of 36 minus M, 34, I kept this number, remember, 343.60 times by 1 minus, 1 plus 0.001 to the power of 36 minus 1 over 0.001. And if I calculate the A value for that, it comes out as 8144.205379 ... So I'm going to deliberately round up, even if I don't need to. 8144.21 is what he now owes as our A value. But of course, I'm maintaining this A value in the calculator. So that's here, 8144.21. And now I can treat that as our present value in our final calculation. So let's just create a little bit more space. And our step 3 is A equals that. P equals 0. We want to finish with 0. So A equals 0. And this is also P. So A or P in that finish with 0 formula. M is equal to, well, we want to know what our monthly repayments have to be now, and the $20 has no effect. We just have to add it on to our monthly repayments at the end. I is equal to 1.5 over 1200 monthly, which happens to be nice again, 0.00125. I say nice, it's nice enough. And N is equal to 24, 2 years monthly. And so our M, or our A, is equal to M times 1 minus, and we're using the same formula as before, 1.00125, I've added that on, negative 24 over 0.00125, and A, of course, is this 8144.21, and so that means that it's equal to M times, and we've got 23.629028 ... which means that M is equal to 344.669498 ... and I'm going to say M is equal to 344.67. Rounding up means it will get paid off, so I'm happy with that. And of course, with the fee, plus $20 fee, so M is now equal to 364.67. And I'm happy with that because compared to what it was equal to here, it's an extra $1. And the interest rate hasn't changed that much. And we're actually paying off fairly quick, so we're paying off more in actual loan than we are in interest. So that $1, I kind of in the back of my head expected it to be a bit bigger, but it's reasonable. It should be more. The interest rate's gone up. The interest rate hasn't gone up much, so it's not going to be much more. Okay, so there's the complex unfamiliar. Two examples here. A fair bit of work. Hopefully that's made sense to you, and of course you can always ask. All the best.